again, and let me sharing the screen. Okay. If it does freeze, again, use the raise your hand feature or something so I can hear you, okay? And in fact, I want everyone to try this example now. Actually, what time is it? Yeah. See, I was going to have you guys try this. You know what? Yeah, take about a few minutes just to get started on this, okay? You know, take like 2-3 minutes. You know, again, just start on it. You know, if you don't finish it, that's okay. Take about a minute or two. So, am I recording? Yes, I am. Let me just. Okay, but again, the notes are now in your email inbox. I just emailed them. Okay, so basically you can notice that there's a non-zero constant term, okay? We have a non-zero constant term. So that tells us when we're finding the GCF, which is what you always want to do first, right? You can see that the variable, you can see that the m is going to be 0. In other words, there's a term here that has no variables in it. So we can't factor out x out of every term. And now let's get the factors of 9, 36, 4, and 16. In other words, we're trying to determine the greatest common factor of 9, 36, 4, and 16. So I did list them already. Okay? And hopefully you can see by looking at the list that the only factor in common to all of these numbers, to the coefficients and the constant term, is 1. So the only common factor is 1. That forces b to be 1. Hence, the greatest common factor of this is just going to be 1. So in other words, we don't factor anything out yet. You know, we can't. I mean, if you've tried to factor 1, that's not going to get you anywhere. All right, that's no big deal, because now we get to do the fun stuff, factor by grouping. Now, as before, we form 2 groups, okay, as you can see, 2 groups, right? And we have to find GCF of each of these groups. We find the GCF of each group. So again, we have our polynomial, we form 2 groups. We now find the GCF of each one. So for the first one here, right, that's what we're going to do. Notice the smallest power of x is 2. So we will be able to factor out x squared. Also, from the previous slide, 9 is a factor of 36. So that tells us 9 is the greatest common factor of 9 and 36. Okay, actually, let me just quickly go back. Let me go back and show you. See, if you look at 9 and 36, you can see that the biggest common factor is 9. That's what I'm trying to show you. Hence, we're going to factor out, excuse me, hence the GCF. So B is 9, right? And the greatest common factor of this alone is 9 times x squared. So from the first group, we're going to factor out this. Okay, and again, how do you factor out? Same old story, right? What you do is this, right? You put it in front, you want to divide, right, to figure out what's left over. And of course, when you divide, you go into each term. You have to divide into each term in a sum. And so by dividing, we get this, right? You can see the 9s cancel. All that's left here is x, right? Because you subtract exponents. Here, the x squares cancel, and 36 over 9 is just 4. Now that's for the first group. For the second group, we have this. 4x plus 16. So we want to factor that. Okay, so let's do it. Okay, well, right away, even before I show you on the slide, although you can probably see it already, but that's okay though, but there's a non-zero constant term. So again, in finding the GCF of this, right, we take m to be 0. We can't factor out x from this term. We can't factor out x because x is not there. Just like with 9 and 36, 4 is a factor of 16. So 4 is the greatest common factor of 4 and 16. It's just like what we had. So because of that, our GCF here is just 4, right? We take m to be 0. There's no x's here. And 4 is a factor of 16. So what do? We factor out 4. And this is how we do that. Everyone is doing. It looks like everyone's good. Cool. Okay. So make sure nobody was confused. Okay. Wait. Okay. That's good. Okay. So this is what we got. Right? We got x. We factored each of those two groups individually, and we got x plus 4 as a common factor. In other words, after we factored each of these individually, right, what we got was a common factor in parentheses, right? We have something in common in parentheses, x plus 4. That's good. We want that. You know, if this was not x plus 4, or if this wasn't, then we would have a problem. So what do? We factor out x plus 4. Okay? And we have to figure out what this is. But this isn't bad. Namely, you divide into each term, like we've done so many times before. And so, okay? And so when you divide as before, x plus 4 is going to cancel, and you end up with this. So boom, we're done. And we stop. In fact, actually, we would have to stop because you can't factor either of those any further. Okay, that's good. Okay, before we get to this new method, let me just pause this and pause the time.